Hello friends, welcome to third lecture on embedded systems. In the previous lecture, we saw various building blocks of embedded systems and applications of embedded systems. And obviously, in this session, I'm going to discuss about the core of embedded systems. As discussed in the previous class, the core of embedded system can be microprocessor, microcontroller, digital signal processor, application specific integrated circuit, or programmable logic devices like FPGA or CPU. This is categorized. These are the devices which can be core of any embedded system. And you see, any of the embedded system, almost 80% of the embedded systems are built around these cores. And we also discussed about how to select a controller or a processor for embedded system, and it depends on the application for which you are designing your system. Okay, now we will discuss the core in detail. In the last lecture, we got the general idea what is the core. Now, in this session, we are going to discuss the core in detail. We will see the difference between the microprocessor and microcontroller, and then we will see the digital signal processors and how they are different from a microprocessor and microcontroller. Okay. Now, let's get started. See, on this board, I have written the difference between the microcontroller versus microprocessor. Okay, and I have done the comparison between the two. Now, first I will discuss about the microprocessors. Okay, now see, your microprocessor is a VLSI chip. It contains a CPU and other additional units. Additional units present can be cache, floating point arithmetic, superscalar units, etc. And there are various additional units which are present, and these additional units make the speed or processing of your microprocessor faster. Okay, now your generally, what does the work of CPU? CPU fetches the instruction and processes the instructions which are there in the program with the help of processor. This is the job of CPU. It fetches and processes the instruction, and your CPU consists of the arithmetic logic unit, control unit, and registers. Okay, and arithmetic logic unit is used to perform arithmetic operations like addition, subtraction, multiplication and division. Okay, this is the role of arithmetic logic unit. Okay, now in the olden days, microprocessors were running on the clock frequency of 4 megahertz. Nowadays, we have advanced processor which run at a clock speed of 800 megahertz to 3.2 gigahertz. Okay, so it has traveled a lot, and a lot of modifications were done in your microprocessors. Okay, fine. So your fetch and execute cycle of your microprocessor is dependent on the clock. Okay, it is dependent on the clock, fetch and execute cycle. Now, when we will see pipelining, we will see fetch and execute cycle also. This microprocessor is a dependent unit. Okay, it requires the combination of other external units like a memory, timer, interrupt controller for its proper functioning. It's a dependent unit. Okay, and various manufacturers like Intel, AMD, Freescale, LSI, NEC Logic, etc. These are the key players in the microprocessor market. Okay. Now next we will discuss about the microcontrollers. Now see, microcontroller is the highly integrated chip. It consists of the CPU, it consists of the scratchpad RAM, ROM flash for storing program memory, then it consists of the IO ports, then we have a timer unit, interrupt controller unit, all is present on a single chip. Okay, and since microcontroller is an independent unit, unlike your microprocessor, microcontroller is a highly used in embedded domain. Okay, and it is a cheap, cost effective, and it is readily available in market. And microcontroller can be domain specific or application specific, or it can be a general purpose. Now, what is the example of an application specific microcontroller? AVR microcontrollers are examples of application specific microcontrollers specifically designed for automotive domain. Okay, whereas your 8051 is a microcontroller, very famous microcontroller, is example of your general purpose microcontroller. Okay, now we will see The differences between the microprocessor and a microcontroller. Okay, now microprocessor is a silicon chip. It consists of the CPU and other additional units, as I already told. Okay, and microcontroller, it is the highly integrated chip. It contains the combination of RAM, ROM, interrupt controller, timer and other circuits on a single chip. Next point is microprocessor is a dependent unit. That is, it depends on the external peripherals and external hardware for its proper functioning. Okay, whereas microcontroller is a self-contained unit. Everything is there on chip. And microprocessor are general purpose in application. For a general purpose, it is used, and microcontroller are application oriented. Okay, now microprocessor doesn't contain built-in I/O ports. Now, how do it communicate with external devices? To implement input-output ports in the microprocessor, we require interface like 8255. Whereas in microcontroller, it is already inbuilt. Input-output ports are present, and you can use input-output ports as 8, 32, or 16-bit ports. Okay, there is no need to interface 8255 in this microcontroller. 8255 is used only in interfacing of a microprocessor because the input-output ports are not present. And for interfacing, for example, you want to interface a stepper motor to 8085 microprocessor, then to interface anything or any other memory chip to your microprocessor, you need a 8255 chip. Okay, because as I said, it doesn't contain I/O ports. Now, microprocessor have limited power saving options compared to microcontroller, whereas a microcontroller has a lot of power saving features. Okay, so because of these reasons, microcontroller is obviously a better option than microprocessor. So it is mostly we are using microcontroller as a core instead of a processor. Okay. Now next is the digital signal processors. Now, what is a digital signal processor? As its name indicates, it is used for processing of signal. It can be 8, 32, 16 general special purpose processor. Okay. Now, here your digital signal processors, they are 2 to 3 times faster than your conventional microcontroller processor. Why? Because of the architectural difference between the two. Your digital signal processors implement the algorithm in hardware instead of implementing it in the firmware. Means whatever the control algorithm is there, it is stored in the hardware. Hardware is required. So it is 2 to 3 times faster than your microprocessor and microcontroller. Okay, and your digital signal processors are used for performing high-speed computations for addition, subtraction, multiplication, division, and where there are various key units of your digital signal processor. I will discuss them one by one in detail. First unit of your digital signal processor is your data memory. Data memory, yeah, correct. Data memory. In data memory, you store required data and other information which is required to process the program. Okay, for processing anything, we require data and code. So the data on which a processing is to be done is stored in a data memory. Next comes program memory. Program memory is a memory used for holding the control algorithm or your code. Okay, it is held in the program memory. Then next unit is the computational engine. That is, as its name indicates, you can understand that it is related with the hardware part of your digital signal processor. Computational engine consists of various arithmetic logic units and they are operating simultaneously. Simultaneously, all of them are operating. Okay, and it consists of the shifters, hardware shifters for shifting operations. So computations are very fast because of the multiple arithmetic unit and hardware shifters. So it performs computation very fast, and it is mostly used in your multimedia application, telecommunication application, audio and video processing, speech processing. Where you require a lot of computations. Okay. Now, next part of your digital signal processor is your I/O ports. That is the input-output port. Now, what is the I/O ports? What do you mean by ports? Now, whenever we are dealing with the process, we are capturing the signal, we are processing the signal, and then we are delivering it at the output. what is the medium through which all this can be delivered? For example, in your communication systems, you require carrier for transferring message signal from one point to another. So similarly, here input-output ports play very important role too. It either delivers the processed signal or it captures the processed signals. Okay, to deliver the process signal from microcontroller to peripheral with which it wants to communicate, we require input-output ports. To interact, in short, input-output ports are used to so that your digital signal processors can interact with the outside world. We require input-output ports. Okay. Now, operations performed by your digital signal processor. What operation it performs? It performs real-time operations like convolution, sum of products, fast Fourier transform, discrete Fourier transform, etc. All those complex computations which a normal processor takes a lot of time. That's why we are using the digital signal processor to save our time and perform the computation fast. Thank you.